I can't hear you.
Okay. Friends, welcome to another session, uh, Azure AI Fundamental Certification Study Group. Today we will be covering the Chapter 3, Introduction to Machine Learning Concepts. So let's go directly into the definition. What is machine learning? Machine learning, in many ways, is the intersection of two disciplines, data science and software engineers. So that's how machine learning started. Machine learning started from the data statistics. So here there are two parts. There are data scientists. Let me. mm, there are two parts. Like there are data scientists who are like preparing the data, coming up with a model, and there are software professionals who use this model to predict future. They build up applications where they integrate the model, and so on the front end you can enter some values and predict the future. So fundamentally, a machine learning model is a software application that encapsulates a function to calculate an output based on one or more two input values. That's what like that's what it means. It means like we machine learning is based on statistics. I was working for a healthcare company where we used to get a lot of data based on the patient data. And we used to build a model that whether if a patient has some kind of disease, is he suffering from cancer, what kind of complications he will have, how many days he will stay in the hospital, whether he will live or not. So they were like data scientists who used to get the data, build the model, and we used to then, based on the model, they used to prepare values. And we used to build applications where we used to show, okay, all the reports for this disease, this patient, whether how many days he's going to stay in the hospital. So that's in data science, you will hear this word a lot, inferencing. What is inferencing? Inferencing is predicting a future value. We have calculated some values like patient, what is his disease, and we are predicting how many days he's going to stay in the hospital. What are his chances of survival? So here is going showing the picture that we are giving a training data to find out a function, calculate. We are sending data. Uh, you're gonna hear a lot of these kind of terms that x. What is x? X is a function, and y is a label. So based on this term, you're gonna hear a lot x and y. X is value, and y is label. So let's get into what kind of machine learning models are there. So there are two types of machine learning, supervised machine learning and unsupervised machine learning. Under supervised is regression. Regression is very simple. Okay, like we'll be seeing this example like based on the weather, temperature, how many ice creams were sold. So based on this, you can predict, okay, on a future date, how many ice creams you can sell in next month, December, all those things. And then there's a classification. Classification is like, as I discussed in the case of patient, whether he's going to live or die, that is called binary classification. And multi-class classification is when you are trying to, there are multiple parameters involved. For example, you want to find a species of penguin. So it could be based on their flip, other attributes. That's how you're finding. And unsupervised machine learning is you are trying to find out some patterns, and mostly clustering is used. So, as I said, Nivedita may have to leave early. So, Nivedita, you want to start for binary classification? Do you have presentation? Do you gonna share some slide or you gonna talk,
Yeah,
Nivedita?
Vika, sure. I will go ahead. Let me share
Okay.
my screen quickly. Able to see my screen?
Not yet.
The slides?
No, not yet. Sure.
Sorry, I don't hear. Do you see
Sorry.
my screen?
Kishore, are you seeing her slide?
No, I don't
No,
see.
no.
You guys are still seeing my slide, right?
Yeah, only
Refresh.
Zoom is seeing nothing else.
Do I have to stop sharing? Were you guys seeing my slide before I was giving presentation?
Yeah,
Okay.
Mhm.
we're seeing your own old screen again because we are seeing your screen.
Able to see my screen now? Any chance?
Yeah,
Okay.
Okay. I have to stop sharing.
now we can see.
Okay, perfect. Yeah, so today I will cover what binary classification does and what is binary classification. Very quickly, I will give a flavor of like classification and how to use it, what parameters, like how to measure it, like the case studies, and yeah, so these are like 2-3 points I'm gonna cover today. Like Bika said, what classification does. Class in a regression, we have like labels and we are predicting something numericals, but in classification, we don't have proper labels, and we have to segregate between two parameters. So here, for binary classification, there are in classification we have different types of classification like binary classification and multi-class classification. In binary, like the term says binary, so binary means two. It predict between two outcomes, whether it's a cat or dog, or between fraud and non-fraud, true false. Like between two outcomes, we have to select, the model has to select between two outcomes. So if the left hand side visualization, it segregates between dogs and cats based on the feature like color, texture, and shape. Each data point represents the bubbles, like the circles, like each data points, or you can say there are multiple images. So it just segregates between based on the boundary. So these are the shaded lines are the boundaries. And the second right hand side, it's between binary classification and multi-class classification. The left hand side actually binary classification between two category 1 and category 2, and it differentiate between two. Thus in multi-class, I'm not going to today on this topic, but multi-class is based on more than two outcomes. um, Second, when to use it, what are the business use cases? um, we can use classification in every field: healthcare, finance, and manufacturing. Everywhere it is actually used. So my background is finance and bank, so I can say like if I give an example, like an user and Mastercard or Visa holder when use the transaction, like he purchased something in Costco or somewhere, so that transaction detail directly goes to the customer. I mean, where the um, Mastercard card usually tracking, like the statistical team, the transaction directly goes there, and they usually see whether the transaction usually fraud or non-fraud within a span of like seconds or something. They usually say is it a legitimate transaction or it's a fraudulent transaction, and based on that they usually put a mark whether it's a um, whether they put it like 0 or 1. 0 is like it's non-fraudulent transaction, 1 is like fraudulent transaction. That's how it works in banking sector. Same as like churn data like different data, whether to respond and not respond the campaign, or like qualify or disqualify the job applicants. So these are many like use cases, real-time use cases of binary classification. You can stop me at any time if you have really doubt. Well, then how to evaluate it? Like what are the metrics? Oh, 1 second. What I did? Okay, yeah. How to evaluate it? Like what are the metrics, or like how to measure whether the classification model we are doing with whether it's working fine or not. So we have there are many actually evaluation metrics, but these are the metrics that I used in my last 2 3 projects. Those are pretty popular, so I collected over here. If you this table is pretty popular among all the machine learning engineers or data scientist analyst. This is called what table we usually called like predict or accuracy table, but it has actually many name. So in the left hand side, we have the predictor labels. Predictor labels are like positive or negative, and these are the original labels. It has also positive, negative, and based on the outcomes, we usually put it like whether it's a true positive or false positive, whether it's a true negative or false negative. So as I noted over there, true positive is like observation is really positive and is predicted to be positive. That is called true positive. You said, okay, this is a fraud. You predicted that, and it's actually fraud. That's kind of true positive. And false negative, it's like the opposite. Observation is positive, but is predicted negative. Um, like said, true negative and false positive, there are 4 outcomes. Based on these 4 outcomes, we usually calculate accuracy of the model, and what is the precision and recall, and F1 score, ROC, AUC curve we usually call, and based on the curve we usually see like how the model works. Not going very deeper here, the mathematical terms, I mean logic are here. We'll go deeper later. Then how to interpret model output for business decisions. Like now we have on your plate, you have all those accuracies. Then how to interpret that with those accuracy, ROC curve, F1 score, true positive, true negative, everything you have. But what to do with that? First of all, we have to see the threshold for those like all those business priorities. This is not like we have everything and this is not final decision. So we have to calculate which threshold is high and which threshold is low based on the true positive or like fear positive. We can calculate like whether it's a higher precision, and we have to check the fraudulent rate more, for example. So like that, I said like choose threshold based on business trade-offs. If missing a positive is very costly, like missing fraud loss, then favor higher recall. And if acting on a false positive is costly, then favor high precision, higher threshold. So this is called cost-based evaluation. Then we usually do monitor and govern, like many govern based on the project. We have to track the matrices in production, like precision recall, false positive rate, or any drift in score distribution, any drift in the previous model. And we usually monitor every month, bi-weekly or monthly, all those drift, and recalibrate the model based on the drift. And then we have to maintain the interpretability, and we have to report the stakeholders the feature importance and what region there is a drift, or like is there any chances of like high scores of this. So we have to make the trust with stakeholders. So this is how we usually interpret the model output. Yeah, that's all for today. Handing over to
Nivedita.
Vikas. Thank you.
Thank you, Nivedita. I'll take over from here.
Yeah.
You guys can
Yeah.
see my PowerPoint. Thank you. So regression. What is the example of regression? As we said, regression, we take a values. We take feature, and like the feature is temperature. For this temperature, how many ice creams were sold? So we are taking this training set, then we will give this to our model. So here's our model. Here we have the temperature here and how many ice creams were sold. So you can see like that's the function came with like fx is equal to x minus 50. So when x is 50 here, y is 0. And then we can see when x is 60, y is 10. So this is how this linear function is calculated. Very simple. And based on this linear function, based on this regression model, we will be calculating iteratively. So when the model is perfect, we have this function. And there are some terms here which I'll go into this. There's a mean absolute error. It's the average of absolute between actual and predicted values. This is the formula, and I'll go into example a little bit later. There's a mean squared error. Basically, your average, this is the average square difference between actual and predicted values. And root mean square error, RMSE. Basically, you're calculating the root square of MSE. MSE is mean squared error. And coefficient of determination, are there. It looks very scary here. Measures proportional of variance explained by model. Let me give you explain this with some example. I have on my OneNote. So here is the data. So this is actual value, but we predicted these values as this one. So these are the predicted values, and these are the actual values. And we can see the what is the difference between actual and predicted. So here is 2 to 1. So here's the 5 number. So this is the first MAE, which is like 5 divided by 3, 1.67. And second one is the square. We are squaring these values. And that is 9 divided by 3 is 3. RMC is square root of 3, 1.73. So how you calculate the R square? This word you have heard a lot. So here you're calculating the value y values, and basically mean of actual is 20, and then your total sum of squares, uh, 10 minus 10 minus 20, 20 minus 20, 30 minus 20 square. That is coming around 200. This 200, and this number is this 9. So 1 minus 9 divided by 200, that will give you the R square. So this term is used a lot. So even if it looks scary to you too, don't worry. Later I will show you the exercise where the software will calculate all these values for us. The machine learning will calculate all these values. Any questions so far
Actually, I'm not able to
on
understand
regression?
final matrix and other stuff like how how this value is calculated. Like final matrix 5 by 3, where the three value came, and
Total number, mean will calculate like this is actual mean. Total, there are three values. So that's what 3. 5 is like it's taking the actual 5 is coming from here, which is expected versus minus actual. So that's
yeah,
this is
yeah,
the
got it.
these are all the formulas, basic formulas. So all will be derived. It's not very complicated. You must guys have sir, even R here so sounds very scary. You can see it's very simple add calculation. Any other question before I move? Okay, it's mean square root, all those functions. Okay. Averages, mean. So binary classification has been already covered by Nivedita. So multi-class classification. Multi-class classification, um, basically here, as I said, there could be in binary class, as Navidita covered, there's only true or false. Where here it could be multiple classes, like penguin. You are predicting which species of penguin. It could be based on the flipper, their length, weight. There could be multiple parameters. So in this, we have two kind of logarithm, one versus rest, and multinomial logarithm. So let's see what is this one versus rest. So one versus rest, also called one versus R, train train one binary classifier per class. Each model predicts class versus others, and final prediction class with the highest confidence score. What does this all mean? So let's say we are comparing, we have a picture of apple, and we are trying to compare against apple, banana, and orange. So model one will calculate, okay, what is the probability of this image is apple versus banana and orange? And same way it will do for others, banana versus apple and orange versus apple and banana. So let's say the probability was apple versus rest was 60-70%. So it will pick up, oh, this is apple. The probability was high. So okay, what are the advantages? It's simple and flexible, work with any binary classifier, independent probabilities you have to calculate, not jointly optimized. So let's take the other one, multinomial logarithm concept. Basically, in this case, you are saying what is the probability it's actually apple. You're not comparing it with any banana or oranges. So you are doing this logarithm against every apple and independently for apple, independently for banana, independently for orange. You are not comparing with that. And highest probability is the final prediction, which are like, okay, if apple have a probability of 65%, so we'll take that. And this range is between 0 to 1. So this is giant optimization, slightly more competition, giant optimization across classes, slightly more computationally complex. So, okay, clustering. Aditya, are you ready for clustering to present today? Aditya, you are mute.
I'm unable to mute. Okay. No, sir. Next meeting I will present something.
So let me go back to clustering. Share my screen. Clustering, as I discussed before, that clustering is type of a classification only, binary or multiple class. But in clustering, we don't have any class. So like we have a data, we had a lot of sales, and we do generally clustering logarithm to find out whether male customers or female customers, and where our customers are located. Are they located in California or Los Angeles, California, Illinois, Texas? So clustering is finding out some patterns in some data. So that is what called clustering. deep learning. Sakshi, are you ready to present deep learning?
Yeah. Just let me share my screen. Okay. So deep learning is an advanced form of machine learning, and it's kind of inspired by how the human brain learns. So we kind of train AI to think like how a human brain works and learns. And we do that by using artificial neural networks. Neurons are like these cells in our brains, right? And in terms of artificial intelligence, they are some mathematical functions. And these functions learn patterns in data by adjusting some weights and parameters. So uh, this side of artificial intelligence has like multiple layers of neurons. Then these neurons, or what do we call this? These neurons are kind of in like layers, like layered. There's a layered structure. So there would be some input layers, and then there could be some hidden layers, and eventually we have an output layer. And each of these layers are used to transform the data. And as complicated the layer pattern goes, the deeper the network would be. And the models that are based on this layered network of neurons is called deep neural networks, also called as DNNs. So these neural networks or these deep learning methods are used to evaluate regression models, which can, as previously explained, that they can like predict numbers, and then classifications, which can predict some categories. Then it can also help in NLP, which is natural language processing. That could be like text to sound, sound to text, and then other areas of AI like computer vision, and some even very complex and high dimensional data problems as well. So the core idea behind deep learning is that there is a function which takes input as a data, and y is like the target output. And this network of like this big network of functions, right, which is used to predict the output. And like I think we've already discussed before, it kind of helps us to evaluate the loss function and predict what the output will be. There's an example in this course where we kind of classify what kind of penguin species that we're trying to identify. So first, we take the features of that particular penguin. So that penguin would have a certain length of the bill, and then a depth of the bill would be there, and it would have like certain flipper length and weight. So using all these features, we can try to predict what kind of species of that penguin would be. Like maybe if we're looking at an image and we're trying to gauge like what species would it belong to. So we look at these features, that would be like our input. And then our output would be a specific species based on all these features. It could be like an Adelaide, Gentoo, or like chinstrap penguin. So how do we classify classify the output under deep learning? The model takes in uh, these features like the bill length, depth, and other things, and then it kind of calculates a probability. It can give us a range of the probability, like shown in this example. It could be like a 0.2, 0.7, 0.1, and then the highest probability would be like the predicted class for it. So for instance, the probability for the penguin to be an Adelaide is about zero point 0.2, and then for like a Gen 2 would be 0.7, and for Chinstrap is 0.1. So the one with the highest probability is probably the species that we're looking at. So this is like a very high level of how deep learning works. So so how does a neural network learn? Essentially, it kind of it initializes certain weights randomly, and then it there's like a forward pass. It generates like a prediction. So there would be some predicted values of it, and it's kind of trained to calculate the loss or error in the output, and then it does like a propagation where it kind of adjusts the weights. So if it feels like the error rate is high or it's not closer to the right output, so it adjusts those weights, and then again it just repeats the steps until it gets closer to the right output. And I mean, like that's kind of how like the brain works, right? Like you do a lot of hit and trial and just try different ways of solving a problem or like finding an output. So it's kind of similar to that, and that's how a deep learning model works. Yeah, yeah, that's all from my end.
Thank you, Sakshi. So a lot of guys. Let me share my screen. For this exercise, this is part of the Microsoft certification. Oh. Running my intro. Sorry. Can you hear me? No?
Yes.
Some wrong. I was starting a browser. So basically, we are running this exercise, launch exercise. So I have this is given as part of the certification guide from the Microsoft. I have already downloaded this data, which we will be using for our exercise. We will be exploring machine learning. So they have given a browser which will help us to generate the model. So let me click the link. So it's loading the ML machine learning engine. So they have given us a website where we can download and play with the machine learning. Okay. You guys can see my screen, right? This machine learning light.
Yes.
Timeout. Timeout. Refresh the page. Let's refresh the page. We can see it's loading here. Hopefully it will load this time. Okay, it loaded. So all we are ready. So first we'll give you the example of the regression. So they have given me the data file for all this data load. So ice cream example. Let's take the ice cream. So this is the data from the file in day of the week, month, temperature, rainfall, how many ice creams were sold. So next, target column. So we are trying to find how many ice creams were sold, and feature column is day of the week, month, temperature, rainfall. So let's train our data. Let's train our model. So here showing model type is regression. There are 200 rows, and these are the features, and these are the target column. So let's start training our model. So training is saved successfully. We can save the model down locally, and this is how the log looks like. And this is how it has plotted the data. And so here, like how many features were used. And here it's calculating all the numbers: mean absolute error, mean squared error, root mean squared error, R square score. So it calculated all those values for us. So basically, closer it is to one, it's good. So you can see it has done everything for us. So now let's test it. I want to know Tuesday, April, can I? May, let's say, November. So it's that's what it's predicting. How on Tuesday, December, for this temperature rainfall, how many ice creams I'm going to sell. Of course, the regression model works. Let's try and know another model. Now let's try the classification one. For classification, I will use the penguins example, which we were using. So there are 344 rows with 5 columns. Target column, we want to find the species. And based on these features, so it's showing, okay, classification, we are trying to find it. Let's train our model. It is trained. So now showing the confusion matrix, all the numbers showing here: feature use, accuracy, precision, recall, F1 score. And so for this length, depth, Philipper's length, this mass, make the prediction. And this is the zero category. So it did it. So let's now try the clustering. So clustering, generally customers, we are trying to find some patterns. 40 rows, 3 columns, average spend, average frequency. So we are trying to find average spend, average frequency, and keep it manual. Let's train. Yeah, next, start training. That is trained. Samples, feature use is showing all the numbers related to clustering. So based on these features, let's make the prediction. So this one here, they belong to cluster 2. So this is how we can make our prediction based on the customer selections, what kind of cluster they belong to. So that concludes our training. So any comments, questions from members?
It's very good. Thank you.
Well,
Thank you, Vikas.
yeah. So, okay, guys, see you next time. You can see as we are going more depth, it's getting deeper and deeper. So, I would recommend to brush up the older one and do volunteer for presentation. So, see you next
Sure.
time.